Okay, I'll be filming a lesson about algebraic equations for grade 9. So, what is the difference between algebraic equations and expressions? So the difference between algebraic equations and algebraic expressions is that an expression you can only simplify an expression. However, you can solve an equation. An equation consists of an equal sign. An expression does not have an equal sign. So we use equations to solve or find information we do not have using information we were given or we have. For instance, if we say, what do we add to 5 to get 9? You represent the information you do not have using a variable, x, y, z, a, and so forth. So you can say, what do we add to 5 to get 9? But, and then you can represent it in equation form. All right? Now, we will be using additive inverses and multiplicative inverses to solve for our algebraic equations. So additive inverses are numbers with the same value or values with the same magnitude but opposite signs. The values must add to give you 0. For instance, if you have 2, the additive inverse of 2 will be minus 2. When you add positive 2 and negative 2, you will get 0. Another example, if you have x, which is positive x, the additive inverse of x would be negative x. When you add them, you get 0. Now, we also have multiplicative inverses. So multiplicative inverses is any number multiplied by its multiplicative inverse will equal 1. For instance, if you have the number 9, and I say, what is the multiplicative inverse of 9? It becomes 1 over 9. When you multiply 9 times 1 over 9, you have to get 1. Hello. So we go again. Another example, 5 over 2. The multiplicative inverse of 5 over 2 will be 2 over 5. The easiest way to see it is that the numerator becomes the numerator, and the numerator becomes the denominator. So if you multiply 5 over 2, 2 over 5, you will get 1. Now let's do some examples that contain additive inverses and multiplicative inverses. So we have 3x plus 4 equals 8. So the first thing you do when you have multiplicative inverses and additive inverses in one equation, you deal with the additive first. So we're going to say 3x, you move the 4 to the other side. You group like terms. In simple terms, you group like terms. So you have 8 here, which is a constant. So you need to move this constant to the other side where there's also a constant. So when a number jumps an equal sign, it changes the sign. So we had positive 4. When positive 4 changes sign, it becomes negative 4. So we have 8 minus 4. 3x equals to 4. To get x, to solve for x, we divide by 3, divide by 3. X equals to 4 over 3. Or we can say 3x plus 4 equals to 8. All right. So the additive inverse, this is another way to do it. The additive inverse of plus 4 is minus 4. What you do on the left-hand side, you do on the right-hand side. So this positive 4 and negative 4 will give us 0. And we are left with 3x. Now 8 minus 4 is 4. Now we have to do, what's the multiplicative inverse? The inverse of 3 You can say 3 over 1. The inverse of 3 is going to be 1 over 3. 1 over 3, yes, 1 over 3 multiplied by 3, you will get 1x. And then you come back here on this side. What you do on the left hand side, you do on the right hand side. So 4 times 1 over 3. Wait, what is that? Yes, it's right here. 1. So 4 times 1 is 4. 1 times 3 is 3. So you have 4 over 3. X equals to 4 over 3. All right. Okay. Let's try another example. Okay, here is another example. We have 3 open bracket x minus 2 close bracket equals to 12. When you have a bracket, you apply a BODMAS, and BODMAS say deal with the bracket first. Using multiplicative, using distribution property. So we're going to say 3 times x, 3x, 3 times minus 2, negative 6, equals to 12. Now you group the like terms. It is now linear, so you can group the like terms. So the like terms that we have are the constants, 12 and 6. So you can move the 6 this side, or use this method and say, what is the additive inverse of minus 6, which is plus 6? Then we are left with 3x equals to 12 plus 6, 18. All right, so the additive, the multiplicative inverse of 3 is 1 over 3. Now you're left with x equals to 18. 18 over 3. X equals to 6. Or the easiest way, like I have shown, or you can just say, after you reach the stage, you can say, you move the 6 this side and say 3x equals to 12 plus 6. 3x equals to 18. Divide by 3, divide by 3, x equals to 6. So you can use whichever method is simpler to you. Okay, let's do another example. No, it's not there, class. I'm just doing this for my staff. Yes. It's okay, you can leave it. You can leave it like that. So, here's another example. We have 5 open bracket x minus 1, close bracket x plus 3. We have x on the left hand side and on the right hand side. BODMAS says deal with the bracket first, using distribution property. So 5 multiplied by x is 5x. 5 multiplied by negative 1 is negative 5 equals to x plus 3. Solving for x means isolating x. Get x on one side and everything else on the other side. So when here we have 5, here we have 4. It is best to always move the x to the side of the highest x value. Here we have 5x, here we have 1x. So it is best to move the one with the lowest value towards the one that has the highest value. So you can say 5x This x jumps an equal sign, so it becomes negative, equals to 3. This negative 5 jumps the equal sign, so it becomes positive 5. So 5x minus x is 4x. 3 plus 5 is 8. Divide by 4, divide by 4, x becomes 2. Okay, let's do another example. So now we have fractions. When you have two fractions, you can use the multiplicative inverse method, or you can use the LCD method. To find the LCD of 3 and 4, the best way or the easiest way, draw a table. You have 3, you have 4. So 1 times 3 is 3, 1 times 4 is 4. 2 times 3 is 6, 2 times 4, 8. 3 times 3, 9, 3 times 4, 12. 4 times 3, 12. You stop when you find the same number in the columns. So we have 12 here, and we have 12 here. That means this is our LCD. 12 is our LCD. Now, how many times does 3 go into 12? 4 times. You say 4, and then write whatever else is left on the top. So what we have on the top is x here. Now plus, how many times does 4 go into LCD? 3 times. Then you write whatever else that is left on the top, which is 2x minus 1. Now, how many times does 1 go into the LCD? 12 times. Then you write whatever else is left here. Now, let's distribute. Here we have 4x plus 3 times 2x, 6x. 3 times negative 1 is negative 3 equals to 12. Now, group like terms. Our x's are already on one side. 4x plus 6x becomes 10x equals to 12. This 3 will jump the equal sign, so it becomes positive 3. So 10x equals to 15. Solving for x, divide by 10, divide by 10. Our x equals to 15 over 10. Okay. Let's try another one. X minus 3. Okay, the same one, let's do it using multiplicative inverses. 5y equals to 3y plus 12. So here you are solving for y. Any variable can be used. It's not always x. It can be y, it can be z, it can be a, any variable. So we are looking for x, for y here. It is already in linear form, so you can group your like terms. So 5y plus 3y will jump an equal sign, becomes 3y equals to 2y. 5 minus 3 is 2, and then equals to 12. Y equals to 2y. Divide by 2. 12 divided by 2, our y equals to 6. Okay, let's try another one. Four. What must say is we must deal with the brackets first. So we are going to use distribution property to get rid of the brackets. So 4 times, okay, let's go. So 4 times 7, 6 times 4, we get 24. 3 times 9, we get 27x. 3 times 8, we get 24. Now it is in linear form, you have to put like terms. So we have 28x minus 27x equals to 24 minus 24. Here we have x, 1x, 28 minus 27 is 1. 28x minus 27x is 1x. 24 minus 24 is 0. So our answer is x equals to 0. Let's find another one that is user friendly. Okay, I think I have another one on my phone. Number 10 over x. Okay, let's plus 3 equals to 5. Okay, equals to 2. Now the only fraction we have is 10 over x. So x is our only denominator. You can either use LCD method and say LCD equals to x, right? Now how many times does x go into our x? 1 time, and we are left with nothing. So you write whatever else is on the top. Plus. So this 3 is not a fraction, but to make it a fraction, you can say over 1. So how many times does our 1 go into x? X times. And then you write whatever else is left on the top. Equals to x. Now let's prove our like terms. We have 10 equals to 8x plus 3x. 10 equals to 11x. Now solving for x, we can say 11x divided by 9. So x equals to, no, 10. 10. Okay, wait. Okay, there's something that I forgot to mention. When you have additive inverses or multiplicative inverse, it is always best to start with the additives first. So we deal with the 3 before we can deal with this denominator of x. So we are going to say 10 over x equals to, this 3 moves to the other side. It becomes 8 minus 3, so we have 5. Okay, let's just write it down. 8 minus 3. So we have 10 over x equals to 5. Okay? So now we can remove this x by using inverses. So the inverse of 1 over x is x over 1. Right? This multiplying this will give us 1. Right? So we are left with 1 times 10. So what you do on the left hand side work, then let's use the LCD method. Okay, 10 over x plus 3 equals to 8. We said our LCD can be x, right? Always deal with the additive first. Now, 10 over x equals to 8 minus 3, 5. Now, let's go back to our LCD. How many times does x go into our LCD of x? 1, and we are left with nothing but what is on the top. Okay, that becomes 5 over 1. How many times does 1 go into x? X times. Then we are left with 5. Right? Then now this becomes 10 equals to x multiplied by 5. It becomes 5x. To solve for x, we divide by 5. Divide by 5. 2 equals to our x. So you can use either one of the methods. Okay? Okay, let's try one last example. Let me see. I wish I didn't take the picture. Okay. Okay, let's try another one. We have 2x plus 6 over 2 minus 2x minus 4 over 3 equals to 2x minus 4. So let's find the LCD. We have 2 and 3. Okay, let's do it then on this side. No. Okay, we have 1 over 2 and 1 over 3. So let's find the LCDs of 2, then 2 and 3. 1 times 2 is 2. 1 times 3 is 3. 2 times 2 is 4. 2 times 3, 6. 3 times 2, 6. So now we solve. When you find the same number on both the columns. Now your LCD means LCD is you. Now your LCD is 6. Okay, now let's solve this. How many times does 2 go into 6? 3 times. So you say 3 and whatever else you have left on the top, which is 2x plus 6. Minus, how many times does 3 go into our LCD? 2 times. Right, whatever else is left on the top. This, you can say over 1, right? How many times does 1 go into our LCD? 6 times. So we have 6, whatever else you have on the top, which is 2x minus 4. Right. Now let's distribute. So 3 times 2x, okay, just go on. 3 times 2x, 6x. 3 times 6, 18. Just make sure, times 6. 18 plus 18 minus 2 times 2x, 4x, plus 2 times negative 2 times negative 4 plus 8 equals to 6 times 2x, 12x, 6 times 4, negative 24. Okay? It is now in linear form. You can group your like terms. Okay, it is always best to bring down the highest x value, to bring the lowest x values to the side of the highest x value. So our highest x value is 12. So let's bring all our x values to the side of 12. Okay, this side we are gonna, on the left hand side, we are gonna now write our constants, our numericals, grouping them as well. 18, plus 8, right? This plus 24, because it's going to jump the equal sign, plus 24, equals to 12x minus 6x plus 4x. Right. We have 18 plus 8 plus 24. Now 50 equals to 12 minus 6, we have 12 plus 4. Oh my God. What did I say? 12 minus 6 is 6 plus 4. We have 10x. 12 minus 6 plus 4. So 12 minus 6 gives you 6 plus 4 gives you 10x. Now solving for x, you divide it by the 10. So 50 divided by 10 is 5. Our x value is 5. So it is okay if your x value is on the right, because x equals to 5 and 5 equals to x is the same thing. Okay? So it is best after you get it like this to say therefore x equals to 5. Okay. We can do just one last one, or this is all? I think that is all. Yes, I think that is all. They said no less than 20 minutes. Yes, they did not say it must be 40 minutes or what. So this is how we solve for x. These are algebraic equations. The next ones that we are going to do, okay, we will have to learn those in the next class of solving for x when x is an exponent. In the next class, we are going to learn to solve for x when x is an exponent. Thank you.